In this lesson, you're going to get your first chance at trying some geometric constructions. So make sure that you've got your compass and your protractor ready. Now first let's talk about a definition we're going to need a little later, and that is that if two intersecting lines form four right angles, then the lines are perpendicular. Here's an example of two lines that are perpendicular. That means that where they intersect, we have four 90-degree angles. Now you're probably used to using a tool that looks like this, that's a protractor, to measure angles, and we could certainly do that with this particular picture and see that we do have four 90-degree angles. But when we do constructions, we're really not going to be using that protractor to measure things in the sense of looking at the numbers on the protractor. In fact, when we measure, we're going to be using our compass. So you'll see how to do that in just a second. Now there's some basic rules that we need to follow for constructions. First of all, when you're doing a construction, the point of the compass can only be placed on points or intersections in your construction. Secondly, as you're constructing, don't erase any of those arcs that you're making for your construction unless it's just an out-and-out mistake and you need to try again. Those arcs are telling the story of your construction. It's telling how you constructed. And thirdly, when we are going to measure something in a construction, we're never ever going to use the numbers that are on those tools. You're never going to use the numbers on your protractor to measure something, and you're never going to use the numbers that you might see on your compass to measure. So with those rules in mind, let's start with our first very basic construction, which is to measure a line segment, and then we're going to copy a line segment. So first let's talk about measuring a line segment. If I ask you to measure line segment AB, it does not mean to get a ruler out and use the numbers on the ruler to come up with a number. Measuring a line segment means to take your compass and put the point of the compass on one end of the line segment and put the pencil, or in my case I have a Sharpie, on the other end. And then I can say this is the measure of that line segment. Now if I want to copy that line segment, I can use that measure that I've just done to make a copy. So the first thing I'm going to do is draw a line segment that's longer than the one that I just measured. I'm going to put a point on one end of this line segment. Now remember we said we can only put points or put the point of your compass on points in your construction. So we've already measured that this is the length of the line segment. I'm going to put the point of the compass on this point. That's the end point of my copied line segment, and I'm going to make an arc that will be the same length as the distance from A to B. So now this arc tells me that this line segment is the same length as my original line segment AB. So if I would label that, let's say CD, then I could say that line segment AB is congruent to line segment CD. That means they're the same length. Now let's see how to construct the sum of two line segments. So here's the construction we just finished. We copied segment AB. Suppose that we want to construct the sum of segment AB and segment EF. The first step would be to do exactly what we did in our first construction. We would want to copy segment EB onto this line segment. Then we're going to measure segment EF, and we'll do it the same way we did with segment AB. That's how long segment EF is. And we'll come back down here to this point D, and we're just going to add on to that. Now my line segment that I'm copying this to is almost too short. If I needed to lengthen it, I would, but I think it's going to work. And I'm going to make another arc here. Remember, that is the same length as segment EF, so the segment that I have just created, and I'll label this point G, so segment CG is the same length as the sum of the lengths of segment EF and segment AB. Now we'll construct the perpendicular bisector of a line segment. Let's construct the perpendicular bisector to segment AB. Now the first thing we'll do is measure a distance that is more than half the length from A to B. We'll put the point of the compass on A and make an arc above and below our line segment. Then without changing the length of the line segment, we'll put the point of the compass on B and do the same thing. Now we've got 2 points indicated by our 2 intersections that we can connect with another line segment. This point of intersection, and we'll call it C, is the midpoint of segment AB, so it bisects segment AB. And these 2 line segments are perpendicular to each other. So now let's look at how to construct 2 different kinds of perpendiculars. So I want to construct a perpendicular to this line, but I want that perpendicular to contain point P. Now remember, the only place you can put the point of your compass is on points and intersections, and we only have 1 point here. So we're going to put the point of the compass on this point, and we'll make an arc to the left of that point, and without changing the size of the compass, we're going to make an arc to the right of that point. Next, I'm going to take the compass and stretch it out a little bit longer, because what I want to do is make 2 arcs that intersect either above or below this line segment. I'm going to make mine above. Now I've got these 2 intersections of these arcs and this line, so my point of the compass can go on those intersections. I'll put the point of the compass on this left intersection and make an arc above the line. And then without changing the size of the compass, I'll put a point on this intersection and make another arc above the line. That gives me 2 intersecting arcs, which really creates another point. And if I connect that point up with the point that's on the line, what I'll have is a line segment, or if I put arrows on the end to indicate that it goes on forever, it could be considered a line that is perpendicular to the original line, and it contains point P. Now this time point P is not on the line, it's above the line. So I want to make a perpendicular that goes through that point that's not on the line, and I want that line to be perpendicular to this original line. Now remember, you can only put the point of your compass on points or intersections, and we only have 1 point. So what I want to do is make my compass long enough so that it reaches down to the line, and actually reaches down a little past the line, because what I'm going to have to do is make an arc on one side and then the other side, and those arcs have to intersect the line that I would like to be perpendicular to. Now I'm going to take my compass, and because I have 2 more points that I have indicated with these intersections, I can put my point on each of those intersections, and I'm going to make an arc. Oh, if I do that, you're not going to be able to see it. Oh, maybe you can. Actually, I would not have to have the compass at the same setting. I could shorten it if I wanted to, but I think you're going to be able to see that. Yep. So make an arc below the line, and then point on this intersection, and make another arc below the line. So now I've got yet another intersection, which indicates another point, and I can connect my original point P up with that intersection. And when I do that, I have a line or line segment that is perpendicular to my original line. Now let's look at how to construct some means. The first mean will be the arithmetic mean of two line segments. Now if you keep in mind what an arithmetic mean is, it's basically an average. It will help you see how to do this construction. So to average two things, we add them together and divide by 2. So that's basically what we're going to do geometrically here. So the first thing I'm going to do is make a line segment that I think is more than the sum of the distances of these two line segments added together. So that looks a lot longer. Okay, next thing we're going to do is copy both of those line segments to this line segment. We've already seen that construction before. So I'm going to copy segment AB down to this line segment. Copy segment CD, so I'm measuring it, to the line segment as well. So this line segment is the same length as AB. This one is the length of CD. So if I go from this point, I'll call that E, to this point that I'll call F, segment EF has a length that's equal to the sum of the lengths of these two line segments. But I want to take this and basically divide it by 2. So that means I need to bisect that line segment. We've already seen that construction. I'll take the compass and stretch it out to more than half the distance between E and F. I'll make an arc above and an arc below, and without changing the compass setting, I will put the point of the compass on F, make an arc above and an arc below. And now I have 2 more intersections. I'm going to connect those intersections up, and I will have a line segment that intersects line segment EF. I'm going to call this point G. So segment GF, the length of segment GF would represent the arithmetic mean of the lengths of segment AB and the length of segment CD. Now let's construct the geometric mean of two line segments. Now this construction actually starts off exactly the same way that the last one did. We need to copy both of those segments to another line segment. So I'll draw a line segment that I know is longer than the sum of those two segments. I'll make a point on my line segment. I'll measure the distance from A to B and copy that distance to this line segment. I'll measure the distance from C to D and copy that distance as well. Now what I want to do is make a semicircle that has these 2 points, and let me just call this one P and I'll call this one Q. So I want to make a semicircle that has segment PQ as its diameter, which means I need to find the center of my semicircle. So I need to find the midpoint of PQ. Now we've done that before. I'm basically going to bisect this line segment. So I'll stretch the compass out so that it's more than half the distance from P to Q. I'll make an arc above and an arc below. And then I'll put the point of the compass on Q, make an arc above, and an arc, whoops, below. I need to make this one a little longer, don't I? That is easy to do. There we go. So now, if I connect up these 2 points, these 2 intersections, and I look to see where that crosses segment PQ, this point right here, I'll call that C for center, is going to be the center of my semicircle. Now if that's the center, then the distance from C to Q or C to P would be the radius of my semicircle. So I'm going to measure that distance about like that. And then I'm going to draw my semicircle. And hopefully I don't slip too much here. Like that. That's okay. I'll come back around here and try to draw from the other direction. Now you can probably see this is a little bit off here. Sometimes in your constructions you will be a little bit off because your compass will slip. That's okay. As long as all of the arcs are there that explain the story of the construction, you've still got a good construction. Alright, so the next thing I want to do is take a look down here at this original line segment. Now remember, from P to this point right here, which we didn't name, let's go ahead and give it a name. We'll call it E. From P to E was this same length as from A to B, and from E to Q was the same length from C to D. And what I need to do is construct a perpendicular to this original line segment that contains the point E. And that's also a construction that we have already done. So in order to do that, I need to put the point of the compass on E and find points on either side of E that are the same distance from E. So there's a point on the right side. I'll just turn the compass around. There's a point on the left side. Oops, make that arc a little bit bigger for you. There we go. All right, so then what I want to do is stretch the compass out longer. And I need to find a point up here that is the same distance from these two intersections we just drew. So here is one arc going from this arc that we just drew. And here is, without changing the size of the compass, second arc going from this intersection. Now that intersection, if I connect it up with point E, will give me a line segment that's perpendicular to the original line. So where is this arithmetic mean? Well, the arithmetic mean actually is this part of that line segment. So rather than connecting up this intersection all the way down to point E, I'm only going to go from where that line segment intersects the circle, and I'll call that F. So line segment EF, the distance, the measure of line segment EF, is the geometric mean of line segments AB and CD. Now the last construction is the most complicated, and it's going to use several of the other constructions we've already done. We're going to construct the harmonic mean of two line segments. So here's our two line segments, AB and CD. We want to construct the harmonic mean. Now what I'm going to do is make a really, really long line segment here that we're going to use to start the construction. And what I'm going to need to start this construction is two things. I need to construct a perpendicular to that line segment through a point on the line segment, and I also need to find the arithmetic mean of these two line segments. So I'm going to start by just putting a point right here. And let's say the first thing I'm going to do is construct the perpendicular to this line segment through that point. So we've already seen how to do that. All we have to do is find two points on either side of this line segment that are the same distance from it. Stretch the compass out longer, and from each of those intersections, put an intersection, or put two arcs, either above or below. I'm going to go above. And then we can connect that intersection with the point, and we've got our perpendicular. Now, we're just going to leave that perpendicular there for a second. We'll be back to it. There's our right angle. So to the left of that point, so over here, I'm going to find the arithmetic mean of these two line segments. So I'm going to measure this distance from A to B, and I will put that measurement right there. I'm going to measure the distance from C to D, put that measurement right here. I now have a line segment that has a length equal to the sum of the two line segments. It goes from, let me go ahead and label this one. I'll label it E, and I'll label this F. So segment EF has a length that's equal to the sum of those two segments. If I bisect it, so I'll stretch this out a little more than halfway and make an arc above and an arc below from point F, and without changing the measure of the compass, make an arc above, an arc below. Those two intersections represent 2 points. I can always connect 2 points up with a line or a line segment. And let me call this point G. So the distance from E to G is the same as the distance from G to F, and those distances are the arithmetic means of segment A, B, and C, D. Okay, so now we have everything we need. Let's look at the right side of this picture. So to the right of point E, which remember is at that intersection of these two line segments that meet at 90-degree angles. To the right of point E, I'm going to copy segment CD. Put it right there. What letter are we up to? Let's call that H. So we've got a point right there at H. And on the line segment that's perpendicular to that one, I'm going to copy segment AB. Let's call that point J. All right, now what we need to do is take this measurement, remember from F to G or G to E, that is the arithmetic mean of the two line segments we started with. And we need to copy that measurement right here. Let me call that point K. So from H to K is our arithmetic mean. So the arithmetic mean is really from here to here. But remember, we're looking for the harmonic mean. So we need one more thing going on here before we can find that harmonic mean. And that is we need to complete a rectangle that will have E and H and J and some other point out here as its vertices. So keeping in mind that the opposite sides of a rectangle have to be congruent, I'm going to measure from E to H, so that's the length of the longer side of this rectangle, and I'm going to copy that length here. And I know that the length from E to J has to be the same as the length of this side of the rectangle, so I'll copy that there. And I've got a rectangle. Let me go ahead and draw it in so you can see it a little more clearly. I've got a rectangle that has vertices at E and H and J, and I guess we'll find another letter of the alphabet to call this vertex L. All right, believe it or not, we only have one more thing to do, and that is we are going to connect up with a line segment, point K and point L. Just like this. Okay, so somewhere in that picture is the harmonic mean. The harmonic mean is actually from this point to this point. Let's call this one M. We haven't used that letter yet. So the harmonic mean is from point J to point M. So now that you've seen some constructions, what you need to do is practice, practice, practice. You only get better at these through practice. If you only do them once, you will not remember all of the steps that it takes to do the constructions.